13 says a rectangle whose length and width are 10 and 6 respectively is shown below. The rectangle is continuously rotated around a straight line to form an object whose volume is 150 pi. Okay, which line could the rectangle be rotated around? Now, the key words here that I see very quickly that should be important to you as well is volume is 150 pi and continuously rotated about one of its straight lines. What should be screaming at you in your head is if it's being continuously rotated around a straight line and it is a rectangular 2D shape, you are creating a cylinder. You're creating a cylindrical shape, okay? Because if I spin around one of these sides, you're going to be creating a circular figure, okay? So that's what you should be thinking of right now. The problem is all of these calculations are going to take a little bit. It's asking you which line could the rectangle be rotated given that the volume is 150 pi. Okay, let's take it slow. Let's go through each answer choice. Let's see what the heck they're asking us to do. Let's take a look at choice 1, alongside. Okay, well, alongside in this case is if you were to rotate the rectangle around the long side, as in you're rotating in this direction. You're spinning it like this, okay? So if you were to spin it like this, that means that this is your radius of the cylinder, and this is the height of the cylinder. Unfortunately, it's on its side. So if you were to just imagine stand it upright, you're spinning it around, this is the height, that's your radius, okay? So the volume formula of a cylinder, this is choice 1 by the way, the volume formula of a cylinder is pi r squared times the height. So in this case, the radius is 6, so we have pi times 6 squared times the height of 10, okay? Ignoring the pi for a second, let's just multiply the numbers. 6 squared is 36, so this is pi times 36 times 10. This, ladies and gentlemen, will yield an answer of 360 pi. So, unfortunately, the long side cannot work because it's asking you for a volume of 150 pi. You see how this is working so far? Let's keep going with this, and let's see what we could get. Let's take a look at choice 2, a short side. Okay, go to a short side. This is your height this time. It's now spinning around the short side, and this is the radius. So really, you're spinning it in this direction, okay? So, volume equals pi r squared times the height. That will give you pi. The radius is 10, square it, times the height of 6. That will give you pi times 100 times 6. That will give you an answer of 600 pi. That is not 150 pi, so that can't work. Now, let's take a look at choice 3. The vertical line of symmetry. Okay, this is tricky. The vertical line of symmetry is here. You're spinning it around like this. This 6, without a question or without a doubt in your mind, is the height. The problem is, what is the radius? The radius is not 10, it's 5. Because what we just did is we just bisected this side down here to get a length of 5 and 5. This is your radius. The 5, not the 10. So because we're spinning it around, basically we just have two actually, the perfect example of the revolving door. If you take two rectangles and it has a central axis, this in this case is the central axis of the spinning doors, and you just spin it around, that's why the radius is 5, not 10. So let's go ahead and calculate it. So number 3, again, v equals pi r squared times the height. This will give you pi. The radius is 5. The height is 6. This will give you pi times 25 times 6. 25 times 6 is 150. Smack on the pi. And ladies and gentlemen, that is your answer. The vertical line of symmetry would be correct. And if you just wanted to know the calculation for choice 4 would result in a answer of 90 pi, so that can't work either. All right, so your answer is choice 3. In my opinion, that was a pretty challenging multiple choice question. Number 14. If ABCD is a parallelogram, which statement would prove that ABCD is a rhombus? We're talking about a rhombus. We're asking for the specific property of the rhombus. Well, a couple things about the rhombus. The diagonals are perpendicular. Actually, let me make some room here. Rhombus. Let's come over here. A couple things that are special about the rhombus. Diagonals are perpendicular. Okay. What else? Diagonals bisect the angles from which they are drawn. And what else? All four sides are congruent. That's pretty important stuff. So now, using all this information, let's go ahead and draw ourselves a rhombus. Okay? Lucky me, I have the tools on my computer. Sweet. Rhombus. Okay. I'm going to label this as A, B, C, and D. Make sure it's just in a clockwise or counterclockwise fashion. You can't be skipping vertices around. So it says here that the measure of angle ABC is congruent to the measure of angle CDA. While that is true in a rhombus that opposite angles are congruent, that is the property of a parallelogram, not the property of a rhombus. Even though that the rhombus has a property, we're looking for the specific property that proves a rhombus. So choice 1 is out. Choice 2 says AC. Okay, so the diagonal. So AC is congruent to BD. Absolutely, positively, no. This is the property of a rectangle. Rhombi do not have congruent diagonals, so that doesn't make any sense. Choice 3. Diagonal AC is perpendicular to diagonal BD to create right angles. Oh, wait a minute. Didn't I just say before that diagonals are perpendicular as a special property of a rhombus? You bet I did. Your answer is choice 3. No questions asked. That is the answer. All right, moving along. 15. Ooh, sweet. Triangle. To build a handicap access ramp, the building code states that for every 1 inch of vertical rise in the height, the ramp must extend out 12 inches horizontally as shown in the diagram below. What is the angle of inclination, x, of this ramp to the nearest hundredth of a degree? So, they're asking you to solve for this. This is a classic SOHCAHTOA question. Okay? So what you need to figure out is if I were to draw a little stick figure here, I call him Pablo. I think Pablo's a cool name. If you draw him there and you take a look and see, wait a minute, that's across from me, so that's your opposite side. And the 12 is next to, that is your adjacent side. If you're using an O and an A, you're using tangent, TOA. So we need to use tangent. So the standard form of this would be tangent of x, angle x in this case, would be equal to the opposite over the adjacent. Okay? We need to find angle x. So the tangent of x is equal to the opposite side, which is 1, over the adjacent, which is the number 12. The problem is, what do we do from here? In order to solve for angle measures, you have to use the key on your calculator called tan inverse. Many of you call it tan -1. It's actually called tan inverse. Doesn't really matter to me personally, but it's called tan inverse. So we're taking the tan inverse of the function that we're doing, which is 1 over 12, or the ratio, I should say. So go to your calculator, use the TI Inspire, make sure it's in degree mode. Click on tan inverse of 1/12. And if you're using the TI 83 or 84, it should be second tan. Enter, we get 4.76. 4.76, your answer is choice 1. Pretty simple stuff, basic trigonometry question. It's on every Regents. Make sure you know how to do it. All right, moving on to number 16.
Okay, so question 16, the diagram below of triangle ABC says that D, E, and F are the midpoints of AB, BC, and CA respectively. So if we know that they are the midpoints, then we know certain information about the line segments. So if F is the midpoint of CA, it cuts it in half. So FA is congruent to FC. We also know that E is the midpoint of CB, so CE is congruent to EB. Some strong dashes to show what's congruent to what. And D is a midpoint, so AD is congruent to DB. So then we also know that ED, FE, and FD are mid-segments. So FE is parallel to AB, so that means FE is half of AB. Half of AB is AD, these 3 dashes, so that means FE also has to be 3 dashes. Same thing with ED. ED is a mid-segment and it's parallel to AC. So ED is half of AC. Half of AC we said was FC, which is 1 dash. So ED is also 1 dash. And then we also know that FD is a mid-segment and it's parallel to CB. So FD is half of CB. Half of CB is 2 dashes. Okay. So the question here says, what is the ratio of the area of triangle CFE to the area of triangle CAB? So CAB, I'm going to show, is the area, is this whole red coloring filled in. The area is what's filled in. Okay. And then we're looking at CFE. So I'll put that in blue. Okay. So now we know that the area is the space within the shape. So how many blue triangles make up the red? So here's my blue triangle. How many of these make up the red? Let's see. We see that all these triangles, these mini triangles, they're all congruent to each other. They all have 1 dash, 2 dashes, and 3 dashes. So now we know that they're all congruent to each other. So how many blue triangles make up the red triangles? 4. So 4 of these blue triangles make up this shape of the red. So we see that the blue to red is 1 to 4. And we notice that all 4 little triangles, all these little triangles are congruent to each other. So that means that they are similar. If they're congruent to each other, then they're similar to the mama triangle. So therefore we know that the area, the ratio of the area is 1 to 4. CFE is 1 to 4, makes up the mama triangle. Okay, question 17. The coordinates of the endpoints of AB are -8, -2, and 16, 6. Point P is on AB. What are the coordinates of point B such that AP to PB is 3 to 5? So this is where we are gonna want to use our graph paper. So I'm gonna draw a line to represent the x-axis and the y-axis. And the y, I'm just going to try to estimate where the middle is. Okay. So we were given that point A is -8, 2. So now I'm plotting -8, 2. So 1, 2, 3, 4, 5, 6, 7, 8, and -2, down 2. So that's my A. And then point B is 16, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and up 6. 1, 2, 3, 4, 5, 6. Okay, and that's point B. So I'm going to connect those 2 points together. So what are the coordinates of point P such that AP to PB is 3 to 5? So my first step here is to find the total parts. And in order to do this, I just add up the ratio. 3 plus 5 gives me 8. Okay. Now my next step is to find the slope of the line. So remember, slope is rise over run. So here my slope, I go up 1 and to the right 1, 2, 3 to get to that next point. So I can keep doing that, but what I can also do is I can count up to B and go all the way over. So up to B is 1, 2, 3, 4, 5, 6, 7, 8. So up 8 and to the right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So up 8 to the right 24. And now my last step here is to divide my slope, the top part and the bottom, by the total parts. So divide each number by 8, and we get 8 divided by 8 gives me 1, and 24 divided by 8 gives me 3. So I'm going to go, since it's positive, I'm going to go up 3 to the right 1. And we're going to make the marks where it is. So up 1 to the right 3, 1, 2, 3. And then from there, up 1 to the right 3, 1, 2, 3. And again, up 1 to the right 3, up 1 to the right 3, to the right 3. And then you should get up to where B is. Okay. So then lastly, it says what are the coordinates of point P such that it's 3 to 5? So A to P and then is 3, and P to B is 5. So we're simply going to go A, so this is 1, 2, 3. And then 1, 2, 3, 4, 5. So this point here is point P. And on my graph, my axes, it's 1 to the right and 1 up. So my point P, that splits at 3 to 5, is going to be my 1 to 1 coordinate. Okay. So that's dividing segments proportionally. 3 steps to do that. Question 18. Kirsty is testing values that would make triangle KLM a right triangle. When LN is an altitude, so altitude, we think 90 degrees. So LN is my altitude, so 90 degrees here. And we're also testing to see if KLM is a right triangle. So that right angle is going to be here. We're given KM is 16. So now we're trying to find which lengths would make KLM a right triangle. So first we're given LM is 13. So we're just going to go through each choice and see. And KN is 6. If we know KM is 16 and KN is 6, then the missing value of NM has to be 10, because 10 plus 6 gives me 16. Okay, so now I see I have 3 right triangles. I have right triangle KLN, I have right triangle MNL, and I have this big right triangle LMK. So now we know that all these triangles are similar, so we can set up a proportion. So if I look in my triangle LNM, I'm given my big leg, and I'm also given an hypotenuse. In my largest triangle LMK, I'm given my big leg and my hypotenuse. So that's the proportion we're going to set up. So big leg over hypotenuse. Okay. So starting with my smaller triangle, it's medium-sized triangle. My hypotenuse is across from my right angle. So my hypotenuse here is 13. And my big leg here is 10. This is my small leg, this is my big leg. And then I'm going to look at my largest triangle. So my big leg is going to be my 13. This is my small leg. And my hypotenuse is across in the right angle, which is 16 of the big triangle. So now we are going to cross multiply. 13 times 13 gives me 169. And 10 times 16 gives me 160. These values do not equal each other, so these numbers don't make KLM a right triangle. So we know choice 1 is not right. Okay, so I'm going to cross off these numbers, and I'm going to try the next numbers. Use a different color pen. So LM is 12, and NM is 9. Okay, so now we are still given a big leg and a hypotenuse for my big triangle, and a big leg and hypotenuse for my medium-sized triangle. So I'm going to do big leg over hypotenuse again. So starting with my medium-sized triangle, my big leg is 9, and my hypotenuse, angle across on the right, the side across on the right angle, is 12. And now I'm going to look at my big triangle. So my big leg is 12. And my hypotenuse is 16. Now we are going to cross multiply. 12 times 12 gives me 144. 9 times 16 also gives me 144. Since these numbers are the same, that means that is our answer. This is the choice that will make KLM a right triangle, choice 2. So we used similar triangles, and we made proportions, big leg over hypotenuse, and we stayed consistent throughout to get my matching numbers.
19. In right triangle ABC, the measure of angle A is 32, the measure of angle B is 90, AC is 6.2. What is the length of BC to the nearest tenth of a centimeter? Draw yourself a triangle. Enough said. A, B, C. 90 degrees. Angle A is 32. AC, which is hypotenuse, is 6.2. We're trying to solve for the length of BC. That's your X. We're using SOHCAHTOA because you know that we're using SOHCAHTOA since we are only given one side length and we're given an angle measure. We need to solve for one of the other sides. We have to use trigonometry. We can't use the Pythagorean theorem here. So this is my reference angle. Again, here's your little stick figure. Here's Pablo. This is your opposite side. And this is your hypotenuse. Well, we have an O and an H. We're using sine. So the sine of 32 degrees is equal to the opposite side, which is X, over the hypotenuse, which is 6.2. From here, you just cross multiply and solve. So it's 6.2 times the sine of 32 equals X. Let's go ahead and plug that into our calculator. 6.2 times the sine of 32. That will yield a result of 3.3. Yes, that's when you round it to the nearest tenth. So 3.3. So X is approximately equal to 3.3. Your answer is choice 1 for that question. Moving on to number 20. This one was a doozy. This one was like, what is going on here? So let me move this over. 20 says, in the 2010 U.S. Census populations and population densities are shown in the table below. Based on the table above, which list has the state's areas in square miles in order from largest to smallest? So what you need to know, and I know that this is a wacko formula, you've probably never even seen it before, but population density, they tell us, is population over area. They kind of tell us right there. It's people over miles squared. People is population, area is miles squared. Notice the square on that? That means area. Again, just to let you know. Now the area, because it's asking you, has the state's areas from large to small. You're trying to find the area for it. But what's the area formula? Well, you need to get A up here expressed in terms of the population density and the population. So the area formula is the population divided by the population density. And that's simply by isolating the A, or the area, in terms of this equation up here. So this is the formula that we need badly. So let's take a look here. Let's calculate the population. Let's calculate the area of all the states. Let's calculate the area for Florida. Okay? The population in Florida is that many people. And this is the population density. I'm going to plug that into my calculator. So we get 18,800,000. These are some wacko calculations. 801,310 divided by 350.6. That yields an answer of 53,626. 53,626. Okay, let's go ahead and try Illinois. Okay, so that right there, when we plug everything into our calculator, that's, let's see, 12,830,632 divided by 231.1. 55519. 55519. Okay? That's Illinois. Now let's find New York. New York is probably a lot less just because it's so freaking populated. But we'll take a look. Where's my calculator? There it is. Okay. So we got 19,378. I thought that there was more. Oh, that's 2010. Yeah, there's definitely a lot more people in New York now. Divided by 411.2. That is going to be 47,126 if you round it up. 47,126. 47,126. And Pennsylvania, the great state of Pennsylvania. That's where Hershey Park is. My favorite park in the world, Hershey Park. If you haven't gone, make sure you go. There's a lot of chocolate there, lots of rides, lots of attractions. Pretty fun place to go to. It is my second favorite destination behind Disney World. 379 divided by 283.9. 44742. 44712. I just calculated all those areas. Now we need to find which one is from the largest to the smallest. Well, the largest is Illinois. The smallest is Pennsylvania. The largest is Illinois. There's that one. The smallest is Pennsylvania. Florida follows, then followed by New York. Boom. Choice 1 is your answer. That was certainly a tough question, folks. Choice 1's your answer. Number 21. In a right triangle, the sine of 40 minus x equals the cosine of 3x. What is the value of x? So you need to know this fact. Pretty important fact. If you don't know it yet, I suggest that you learn it. Sine and cosine are cofunctions which are complementary. Complementary, if you don't know what that means, complementary means 90 degrees. So what you need to do is you actually just need to, it's very simple. Take the inside pieces of your sine and your cosine, add them together, and set it equal to 90 degrees. I'm not going to get into the specifics of why that is. I could go through a whole long proof. Basically, if you just plug in any value of x that makes the sum of those two numbers add to give you 90, the sine of whatever that number is inside is equal to the cosine of its complement. Okay? So let's go ahead and find the value of x. Actually, once we find the value of x, I'll prove it to you. Here we go. So we get 40 plus 2x. Just take the negative x and add it to the 3x. You get 2x equals 90. Subtract the 40 on both sides. All right, we get 2x equals 50. Divide by the 2 on both sides, and we get x is equal to 25. That is your answer, folks. Let's make sure it is. If we take 25 and we plug it into both of these expressions, we get the sine of 40 minus 25, which is, what is that, 15? 15, yes. So the sine of 15 is equal to the cosine of 75, okay? Is that true? When we take 25 and we plug it in, okay? If we go to our calculator and we type in the sine of 15, does the sine of 15 equal the cosine of 75? Hey, they tell you it's true because, again, sine and cosine are cofunctions which are complementary. Your answer is choice 4.
Question 22 states a regular decagon. So that means we know that this has 10 sides. Is rotated n degrees about its center, carrying the decagon onto itself. So it's rotated fully to get it back onto itself. That's 360 degrees rotation. But we want to find out how many degrees it takes for each turn. So we take that full rotation divided by the number of sides, and we get 10. So 360 divided by 10 gives me 36 degrees. So we want to find which one of these answer choices rotates by a certain amount of degrees to carry the decagon back onto itself. So 36 obviously isn't an answer choice here. So what I'm going to do is I'm going to state each rotation of the decagon. So 36 times 1 rotation is just 36 degrees. So that's obviously not a choice. 36 times 2, so if it's rotated twice, it's rotated 72 degrees. That's not an answer. 36 times 3 gives me 108 degrees. I don't see that. 36 times 4 gives me 144 degrees. That's not there. So we automatically can cross off 10 because we passed that number. That wasn't even an option. It started at 36 degrees. 36 times 5 gives me 180 degrees. We do not see that here. Choice 2 cannot be the option. 32 degrees multiplied by 6 gives me 216. I do not see that. 36 times 7 gives me 252 degrees. I see that, so this is my answer choice. So it's rotated 252 degrees to land itself back on to itself. Question 24 states, what is an equation of the perpendicular bisector of the line segment shown in the diagram below? So when we're talking about equations and we see perpendicular, we automatically think slope. And for a line to be perpendicular, we know the slope has to be the negative reciprocal. And we know negative reciprocal means flipped and rotated and negated. Okay. So my first step is to find the slope of this line. So remember, slope is rise over run. So I'm going to start at this bottom point. I'm going to go up 1, 2, and I'm going to the left 1 to get to this next point. So it's positive 2, I went up, and I went to the left, so that gives me negative 1. So that is my slope of this line. So that means my perpendicular slope has to be the negative reciprocal of this. So first I have to flip it. So negative 1 over 2. So it's going to be 1 over 2 and negate it. Since it's a negative here, it becomes a positive here. So now I know my slope. So now I have to go through each of these answer choices and see which one matches my slope 1/2. Okay, so we're going to try slope choice 1 up here. So we're given y plus 2x equals 0. And remember, we want it to be in y equals mx plus b form. So the x is on this side. We want it away from the y. So I'm going to subtract 2x on both sides. And we're left with y is equal to negative 2x. And there's no y-intercept, it's just 0. So I can leave it as negative 2x. Does negative 2 match my perpendicular slope? No. So choice 1 is not correct. Choice 2, y minus 2x is equal to 0. So I want my 2x on this side, so since it's negative right here, I'm going to add it to both sides. I get y is equal to 2x. My y-intercept is 0, so I'm just going to leave it out, or you can write plus 0 if you'd like. This 2 matched my perpendicular slope, 1/2. No. So choice 2 is not the correct answer. Choice 3 gives me 2y plus x equals 0. So my first step here is to get the x away from the y, so subtract x on both sides. We get 2y is equal to negative x plus 0 you can do. And then my y is still not alone, so I want to get that alone. So I divide y and each other term by 2. I get y is equal to negative 1/2 x plus 0. Does negative 1/2 match my perpendicular slope of 1/2? No. So now we're just left with choice 4. So let's check choice 4. So we're given 2y minus x is equal to 0. My first step, add x on both sides. And we're left with, we get 2y is equal to x plus 0, I can say. And then I have to get the y alone, so divide by 2. And we get y is equal to, there's always a 1 in front of that x, so 1/2 x plus 0. Does 1/2 match my perpendicular slope 1/2? Yes. So choice 4 is my correct answer for question 24.